Hi, welcome to the BioPharma Finder help video. In this help video, I'm going to explain how you bring in a target protein sequence for the intact workflow. So there's a difference between loading a protein sequence for peptide mapping and intact analysis. And the key is when you're doing intact analysis, you need to have the monoisotopic mass or the average mass for the target protein is what the software is actually going to look for. So the example I'm going to show you is for an antibody. And in this case, we know that the antibody has 2 copies of a light chain and 2 copies of a heavy chain. So when we bring in that information into the software, we need to make sure if we're looking at the intact antibody that we have 2 copies of each of the chains. So for example, in this FASTA file, I show you that I have the light chain here, then I have heavy chain, then I have just another copy of the heavy chain, and I have another copy of the light chain. Now I like to put it in this order, so I have light chain, heavy chain, light chain, because when I link the disulfide bonds together, that actually helps me in doing the linkages. But you can bring it in whatever order you'd like. This is the order I find to be the easiest. So you can put it in a FASTA file like this and then import it, or you can actually copy it into the software. This is the sequence editor in the BioPharma software. You can actually copy the information in here. I just prefer to use the FASTA file. So let me browse for the FASTA file. Once I find the FASTA file, so here's the FASTA file, and I put a little tag intact so I know it has the multiple copies. And now you can see that you have the light chain, heavy chain, the second copy, the second copy. Now again, if this is intact, the software is going to try to match it to this target protein mass. And so in this case, we're looking at 145,000 Daltons for the intact protein. Now the software also gives you the chain masses, so you can see the different masses of the individual chains. However, it does not search for the chains. Okay, it is not going to look for these individual masses of the individual chains. However, if you want to do that, you can actually create a sequence for each one of the chains individually, and then you can add multiple chains to the software. I'll also create another help video to show you how to do that, so this one's not too long. But now once we have our protein into the software, and if this is an intact study and the disulfide bonds are not reduced, we must link the disulfide bonds to get the correct mass. And so to do that, as I'm showing you, you click on a cysteine, click to the left, create a link, and then go to the next cysteine and just create a bridge. And so in this example, I have a light chain to a heavy chain linkage right there. And so you just go through and create all the linkages. So it's important that you do that so that you get the correct mass for the protein. And if you notice, as I build these disulfide bonds, the target mass for the intact protein up here, if you watch that, that's actually changing. So this is how, and if you don't do this, of course, you're not going to get the correct mass. And these bonds are the hinge region of this protein, and so we go through and just connect those. So once you have all your disulfide bond links together, you would also want to think about any type of static modifications that you might have in this molecule. So I know for this specific antibody, I have a modification on the N-terminus. And so what I'm going to do, I would finish linking all the disulfide bonds. So I'm going to click on the Q. So I double click on the Q, and this is an N-terminal modification to pyroglue, so right here. So I'm going to apply this modification as well. And so this is a pretty big modification, so we lose 17. So if you don't apply that, your mass is definitely not going to be correct. So also the mass will change, so if we watch it, it will change whenever we apply this modification. So, and it's on both heavy chains because we have 2 copies of the heavy chain, and so now the mass has changed. So once you have all your disulfide bonds linked, and you add any static modifications, you can come and look at the variable modifications. And so here, You could choose between two different glycans. So this is for N-glycan modification. We have a CHO database and we have a human database. And you can select either one of these. There's about 200 different glycans in the databases. And so this is a very extensive glyco search whenever you're choosing one of these two. The other option that you might have if you're interested in doing is you could just add the masses of some standard glycans. And so you, in this case, I have a G0F and a G0F combination, or you could add them individually. Now to do that, and you'll notice that these are purple, the reason they're purple is that they're custom modifications. So you could do that by doing Modification Editor, and you can see that I have them, where are they? Let's see, right here. So right there's one of them, and so you just basically add a modification. You could name it, you know, whatever you want to name it. Whoops. And then you can put your residue and then put your mass, your average mass and your monoisotopic mass. It'll appear here, and you go back and then you just select these as variable modifications. Now one trick thing is you don't want to use these for peptide mapping. So if you look for the glycans this way as variable modifications in peptide mapping, what is very important to know is that it's not going to think of them as glycans. Okay, it only recognizes when you do it this way. And what that can do is that will, the software uses a special fragmentation prediction for glycans. So if it knows it's a glycan, it's going to look for the common fragment ions for glycan fragmentation. If you add it as a variable modification, it will not look for that. So your scoring will be low. So your confidence score for this type of variable modification will be low. So if you're doing peptide mapping, you want to use one of these databases, or just be aware that whenever you add a glycan like this as a variable modification, you should lower the confidence score to probably 0, so you can then see the actual match, because it will not assign the glycan fragments unless it's from the database. Okay, so once you've done all this, now you have the correct mass here in your target protein sequence for your intact molecule. Okay, thank you. I hope this video is helpful.